This is a D&D character, Douglas. In his very first adventure, he encountered a maze from whose walls fatal, poisonous creepers are hanging. Reaching the exit seems rather simple, right? Go left, straight forward, right, and straight forward again. Well, not for Douglas. His stats are really, and I mean really low. And let me tell you, he cannot see, hear, or feel at all. So how can we help him learn and reach till the end on his own? Could we make Douglas artificially intelligent so that he can learn to reach the end? Maybe we can take inspiration from the nearest intelligent being. And that is the person you're seeing on your screen at the moment. Yes, you. And big reveal through natural selection and evolution. This process for AI training is called the genetic algorithm. And it works just like how nature does. Just like every other algorithm, the genetic algorithm is composed of some steps. Step 1. Creating a population, giving them a brain. We create hundreds if not thousands of Douglases. Because our objective is to reach the exit, which is a motion-based task, we modify their brains to be composed of 3 simple vectors: position, velocity, and acceleration. Step 2. Mutation and crossover. Here's where the diversity comes in. Similar to biological mutations, we add random vector values to Douglas's brains so the population can evolve. Via crossover, we combine the features, vectors in this case, of the best pair from the last generation. But how can we select the next pair? Step 3. Fitness and selecting the next generation. This step is basically the survival of the survivor. We assign every single individual in the population a fitness value according to how well they performed on this task. The higher the fitness, the higher the probability of survival. Think of it this way. In a population of red and green butterflies, because their natural habitat is mostly green, red butterflies are more distinguishable and thus are more likely to be hunted by a bird. So green butterflies will have a higher fitness and a higher chance of survival when compared to red butterflies. And so, we will expect green genes to pass on to the next generations. Then we select a pair from our population according to fitness scores, and clone them for the next generation, hence completing our loop. So every generation from then on will be better and better than the last one. But not only does this method have a use for D&D. Many business reports and schedules, machine learning cities, and even non-existent online games are actually inspired by how nature works. So maybe next time we look at breakthroughs, we may be able to see the mysterious world of AI learning behind.